Hi everybody. This video begins a new series called Random Calculus. The aim of the series is to just tackle some interesting calculus problems in a non-systematic way. So I won't really start from the foundations and build up in a kind of formal sense. It'll just be like random problems and the things that I find interesting, or just random things that I wanted to know. So yeah, I started this problem by thinking about two different parabolas, one opening up and one opening to the right, and I wanted to know what that shaded area was in between those two, because I just didn't really have a good sense of what that area is. It's clear that it's contained within this little 1 by 1 square, that little shaded area, but yeah, so I mean, of course, it's going to be less than 1, but let's actually calculate what that shaded area is, and we'll use some tools from Calc 2 to figure that, or actually Calc 1 to figure this out. So anyway, let's get into it. So the first thing we want to know is that whenever you're trying to find the area between two curves, you're always going to do, if you're integrating with respect to x, you're always going to do the upper curve minus the lower curve. So that's what we'll do here. We'll integrate with respect to x, and we'll do the upper curve minus the lower curve. Well, note that if we're doing this with respect to x, we need to take the curve x equals y squared and get it so that we have something of the form y equals. So this is the same thing as saying that y is the square root of x. So this red curve for this portion of it right here, that's just y equals the square root of x. So that's the upper curve. And of course, the lower curve we already know is this black one, which is y equals x squared. So this is the upper curve, and then the lower curve is y equals x squared. All right, awesome. So now that we have all that, in general, it's always upper minus lower dx. And then you have to determine what the bounds of integration are. But in this case, it's fairly clear what the bounds of integration are, because if we're moving from here, we're looking at the shaded region. We'll start with the leftmost point. We see that the leftmost point of it with respect to x is 0, and the rightmost point of this region with respect to x is 1. So we can see that we're integrating from 0 to 1. So this is the integral from 0 to 1 of, and then the integrand will be upper minus lower. So the upper curve again was the square root of x minus the lower curve, which is x squared dx. Awesome. So next, we really just need to apply the power rule of integration to this problem while thinking about the square root of x as x to the 1/2. So I'll just rewrite it one more time to write it like that: x to the 1/2 minus x squared dx. Okay, awesome. Lastly, we're just going to apply that power rule. So in case you forgot, the power rule says that the integral of x to the n dx is the same thing as x to the n plus 1 over n plus 1 plus c. And then, of course, this is provided that n does not equal -1, because if n did equal -1, then this would be 0. And then you'd be dividing by 0, which would of course be bad. So yeah, anyway, so this is the formula we'll use here: x to the n plus 1 over n plus 1. So of course that's going to be x to the 1/2 plus 1, so that's x to the 3/2 divided by 3/2, and then minus x to the 3rd over 3, and then we're going to integrate this from 0 to 1. So applying the fundamental theorem of calculus, we just plug in 1, and then we plug in 0, and then we take their difference. So we plug in 1, and we just get 1 divided by 3/2, so that's 2/3 minus 1/3. So that's the first. It's plugging in 1. And then, of course, if we plug in 0, we're just going to get 0 minus 0. So 2/3 minus 1/3 is just 1/3. So that is the area bounded between the curve y equals x squared, this black curve, and the curve x equals y squared, or in other words, the curve y equals the square root of x. So yeah, this is that area. That area is 1/3.